Hi students, in this session let us discuss some important questions from the chapter Alkanes. Okay, so the first question is which compound has the highest melting point? Okay, here four compounds are given. The first one is the N-octane and the second one is the 2,5-dimethyl hexane. Okay, it is a 2,5 dimethyl hexane, and next 2,3,4 trimethyl pentane, 2,3,4 trimethyl pentane, and next here fourth compound bicyclo 2,2,2 octane. The bicyclo 2,2 octane means here this one, the bicyclo 2,2,2 octane. Okay, so which compound has the highest melting point? So generally melting point is explained on the basis of its symmetrical structure. So here among all these compounds here, for suppose here N-octane means here that is a straight chain compound. Here among the all given compounds, this compound has a more spherical structure. Here high more spherical structure means here there is a effective packing in its solid state. That's why here among the given compounds here bicyclo 2,2,2 octane has a higher melting point. Okay, more spherical structure, more melting point. That means more symmetrical structure. Next here, this is the another one. Is some interesting, but it is a basic question. But here in this question is given differently. Give the IUPAC name for the compound and specify the stereochemistry also. Here in this case, isobutyl, tertiary butyl, N-propyl, neopentyl. It's a chiral carbon actually. Okay. So here in this case here, what is the structure of this compound? You can write the structure of this compound. N-propyl means here CH2, CH2, CH3, N-propyl. Neopentyl means CH2, CH3, CH3, and this is the CH3. It is a neopentyl group actually. So next tertiary butyl means here CH3 and CH3. This one CH3. Next here isobutyl CH2, CH3, HCH3. That is the total structure. So here in this case, which compound that means which group has a high priority? So here in this case, tertiary butyl group gets a high priority because attached carbon is a tertiary carbon. And next here CH2 CH2 common, but here second carbon proceed with further carbon CH2 CH2 common, but here this second carbon is a tertiary carbon, but this second carbon is a quaternary carbon. So this one gets a high priority. And here between these two here CH2 here CH2 cancel. Next here CH, but it is a CH2. This group gets a high priority. Third priority, this group fourth priority. So here first priority, and next second priority, third priority group, fourth priority group. So here 1 2 3 take an arrow. That arrow is in anti-clockwise direction, but here least priority group on the horizontal line, so you should take the reverse. So its configuration is R actually. Okay, now here what is the IUPAC name of this compound? So take the longest parent child. So here in this case 1 2 3 4, okay, 4 5 6 7, 1 2 3 4 5 6 7. So here in this case 7 carbons are possible in a two ways. That means here there is the possibility of the equal length of parent chains. Now then here we have to take the parent chain with more number of substituents. So here in this case it is the first carbon, second carbon, the third carbon, fourth carbon, the fifth carbon, sixth carbon, here seventh carbon. Okay, if you take it is parent chain 1 2 3 4 5 6 7 carbons, but here you are only one substituent. If you take this one here, more substituents here, 2 dimethyl actually. Okay, 2 dimethyl actually. Now here in this case here on the fourth carbon isobutyl group, on the fourth carbon tertiary butyl group. So here in this case 4 isobutyl and 4 tertiary butyl. Okay, 4 isobutyl, 4 tertiary butyl, 2,2 dimethyl heptane. That is the IUPAC name of this compound. Okay, here in this case we have to write the tertiary butyl group first actually. Okay, 4 tertiary butyl, 4 isobutyl, 2,2 dimethyl heptane. That is the exact IUPAC name of this compound. Okay, and the configuration is R configuration. In IUPAC nomenclature we can use the isobutyl and tertiary butyl. Those common names also we can use in IUPAC naming. Okay, or we can give the systematic nomenclature also. Systematic nomenclature means here it is a 1 dash carbon, it is second dash carbon, 1 dash dimethyl ethyl. Okay, that's IUPAC name is 1 dash dimethyl ethyl. For this group systematic name, that is IUPAC name. Next here for this group 1 dash 2 dash 3 dash, that means here 2 dash methyl propyl. That is systematic name for that group actually. Okay, so here in this case 1 dash dimethyl ethyl, here 2 dash methyl ethyl, which one comes first in alphabetical order. Here in this case 1 dash dimethyl ethyl comes first, because here we have to consider D actually. Okay, for suppose in this case 2,2 dimethyl, we have to consider in alphabetical order M but not D, because what is the name of the substituent? Methyl is the name of the substituent, but here what is the name of the substituent? Dimethyl ethyl is the name of the substituent. Okay, it is the its IUPAC name is the dimethyl ethyl is the name of that complete substituent. So that's why we have to consider D here. But in case of the simple substituents dimethyl, diethyl, like that, here, there we should not consider D actually, because the name of the substituent is not dimethyl, the name of the substituent is methyl, but that is repeated 2 times. That's why we should not consider D here, but we should consider M. But in this case its IUPAC name is 1 dash dimethyl ethyl. That means here the name of the substituent is a dimethyl ethyl. That's why there we have to consider D actually. Okay, so here in this case 4 1 dash dimethyl ethyl. Next 4 2 dash methyl, here in this case 2 dash methyl propyl. Total name here 2,2 dimethyl 2,2 dimethyl heptane is the IUPAC name. Okay, that's it. The main point is here in this case is in systematic name to methyl propyl, here dimethyl ethyl. Here dimethyl ethyl comes first in alphabetical order over the methyl propyl. Okay, which compound has the highest molecular dipole moment? Okay, this trans compound molecular dipole moment is 0. Next, anti-conformation of 2,3 dichlorobutane. Okay, its dipole moment is also 0, because here anti-conformation, hydrogen here, hydrogen. So exactly their bond moments cancel each other, dipole moment 0. Next, take a C2Cl2 means a Cl, C triple bond, C Cl. Its dipole moment is also 0. Next here cis 1,3 dichlorocyclobutane. Here in this case cyclobutane is the structure of this one, cyclobutane. Cis means here Cl downward, here Cl is also downward. That means here those two bonds in the same direction. So here their bond moments are added each other. So here dipole moment not equals to 0. So this one has the highest dipole moment among the given compounds. Okay, that's it. Next here, the one more question. How many constitutional isomers exist for C6H12 that have a cyclopropyl ring in their structure? So in their structure, cyclopropyl ring must be there. So here the cyclopropyl ring and remaining N-propyl, okay, or that may be isopropyl, or we can write like this here, ethyl, methyl. Now here we can change the position of the ethyl and methyl. Here in this case one more structure is methyl, here methyl, methyl, and one more structure is this one, methyl, methyl, methyl. So totally 6 structures are possible. Here in this case the question is given cyclopropyl ring their structures. So here in this case N-propyl, here isopropyl, ethyl, methyl, here one position, here one two position, here in this case methyl, 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 their position we can change this one like this. Okay, that is one more uh, structure. So totally six structures are possible for this compound. Okay, that's it. Next here one more two more questions. Which compound is the least strained? So here in this case cis-decalene, here it is a trans-decalene. Okay, here the trans-decalene is a least strained compound actually. Okay, here in this case yeah, this one means it is a cis-decalene actually. Okay, in a cis-decalene we can write like this here. It's the axial bond actually. Okay, it is cis-decalene. Now trans-decalene is like this. Okay, this one here in this case hydrogen, here hydrogen. So here in this case it is a carbon carbon bond, here hydrogen, here hydrogen. There is a 1,3,1,3 diaxial repulsions, here first bond, here third CH bond, here first bond, here on the third carbon CH bond, here C 1,3,1,3 diaxial repulsions. It is a less stable. Okay, trans-decalene is a less cis-decalene is a less stable. Here this is trans-decalene. Okay, this is a trans-decalene, upward hydrogen, downward hydrogen. Here in this case there are no 1,3 diaxial repulsions. Okay, next here at the double bond carbon, here at the bridgehead carbon double bond is not exist from the Brett-Stoll. Okay, from the Brett-Stoll planarity is not exist at the bridgehead position, so it is also a strained compound. Here in this case, okay, it is a three-membered ring, so it is also strained compound actually. Okay, so here in this case which of the following is the least strained compound means here this trans-decalene is the least strained compound. Okay, that's it. Next draw the most stable conformer of each compound. Here in this case isopropyl OH methyl. While writing the most stable conformation, here isopropyl the group must be in equatorial position, because here the bulky group always prefer to stay equatorial position. Okay. Here in this case, this OH, isopropyl and this OH. Okay. So here I am writing like this here. Isopropyl group, here equatorial position, and isopropyl group axial position. In this axial position, there is a 1,3 diaxial repulsions. That's why this isopropyl group must be written in equatorial position. Now here with OH, it is in trans position. That means here this OH, this isopropyl group equatorial means downward direction. This OH must be here trans means here this OH must be upward direction. Okay, that's it. Next here this methyl, this isopropyl and methyl are in a trans position each other. So here actually this position is a downward, here this position must be upward. Okay, that's it. That is the most stable conformer of this compound. Here in this case it is the upward direction, here it is a downward direction, trans each other. Now here these are also trans, it is a downward direction, it is upward direction. Okay, trans each other. Next here coming to this one, isopropyl again must be written in a equatorial position. Now these two are in a cis position, it is a downward direction actually, upward direction hydrogen. Here in this case this OH is in cis position, so isopropyl is downward direction, this OH also downward direction. Now isopropyl and methyl trans each other, it is a downward. Now here trans means here methyl is a, must be upward direction. Okay, that's it. So that is the most stable conformer. Now here in this case methyl equatorial position, isopropyl equatorial position, OH equatorial position. Here in this case isopropyl equatorial, methyl equatorial, and OH axial in position. So here in this case all groups are in a equatorial position, here all groups are not in a equatorial position. Okay, so here in this case this conformer is most stable conformer. Okay, because all groups are in a equatorial position. That's it. Thank you for watching.